Hello students, welcome to the next lecture on the multivariate normal distribution. Today I will teach you how you can find the transformation of the multivariate distribution. Myself Dr. Harish. You can follow my YouTube channel where you can find the playlist of the applied mathematical analysis and you can see the bivariate and the normal distribution, multivariate normal distribution lectures in this playlist. You can subscribe my YouTube channel so that you can get the notification in advance for the related complete lecture series on the multivariate normal distribution. So what is the objective of this lecture is we will see how you can find the density function of the transform random variable. What is the meaning of that? That means if you have a random variable x which is given to be as a multivariate normal distribution, then how you can find the transformation, how you can find the distribution of this transformation, that is a new variable y. Again, how you can find the distribution of these two variables, how you can find the so you can see this is the transformation. Or in general, you can see if x is a multivariate normal distribution and you can take any of the transformation, that is a y is equal to cx, then what will be the distribution of this y? Whether y will be again the multivariate normal distribution, whether the y will be the bivariate normal distribution, or y will be the simple one-dimensional normal distribution, or y will be a chi-square distribution or any of the others. So that's the objective of this today's lecture. Now I can quickly recall you what we have did in your previous lectures. Like whenever you have the one-dimensional problem, that means if you have the variable x and your target is to find the, if I say x follows my exponential distribution, for example, fine, how you can find the density function of y which is sin x, how you can find the density function of the x square, how you can find the density function of the 2x plus 1 and so on. So that we have discussed in the one-dimensional random variable. We have found the PDF by using this transformation formula. However, if you have the two-dimensional random variable, like if x and y will follow certain distribution, then how you can find the distribution of say u which is x plus y, which distribution it follows, or how you can find the distribution of x minus y, how you can find the distribution of 2x plus y and so on. So that for that case we have used this bivariate lecture of this, and J is called as the Jacobi. So that up to here we have discussed in this previous lecture, that is for the one dimension and for the two dimension. Now before understand this transformation, you must watch my previous lecture of the multivariate normal distribution available at here. You must subscribe my YouTube channel so that you will get the notification whenever I will upload the complete lecture series on this multivariate normal distribution. So let me quickly recall you the definition of the multivariate. If a random variable xi I varies from 1 to p is said to be the multivariate normal distribution if you can return x is mu plus a into z, where this a is my p cross p non-singular matrix, fine, and this z is my normal distribution with 0 and I is the mean and variance, and all are my independent, fine. So you can see if there exists a independent random variables zi and a p cross p non-singular matrix such that you can return like here, then this x is called as the multivariate normal distribution. Now this is the first result which is a very important. This is a very important result in the field of the multivariate normal distribution. What he suggested that if x is a multivariate normal distribution and a non-singular transformation, remember the word is non-singular. What is the meaning of the non-singular is determinant of C should be non-zero. Then the distribution is y is again a multivariate normal distribution. That means if x is a multivariate normal distribution, take the non-singular transformation, that is also the multivariate distribution with the same parameter p, but the mean and the variance are changed. Or you can also read this statement like here, if x follows the multivariate normal distribution, C is any non-singular p cross p matrix, then C of x will follows this distribution. Remember, what is the meaning of the non-singular is? Determinant is non-zero, or you can say the rank of the C is my P. So remember, this P is basically the rank of this matrix C. Now the proof is very simple. What is given to you? X follows multivariate normal distribution here. So what is the definition of the multivariate normal distribution? You can written X is, that is a mean, mu plus A into Z. Fine. That means by definition here, where A is your non-singular matrix and Z will be my normal distribution of 0, 1, such that this positive covariance, what is that? This is my positive covariance matrix, and the relation between the positive correlation matrix with the non-singular matrix is my here. Now your target is to find the value of the Cx. Fine. So that's a very simple. Now since X is my here, so what does it mean? Cx will be C of mu plus Ca into Z. Clear? Now clearly say which is, again, if I call this is say my Y, this is my say capital mu, I call this is say my B, for example. Fine. And if you compare them, which is again of this form, so what does it mean? That means Y will follows the multivariate normal distribution with the mean is mu, and this is my sigma is already written, I say gamma. But what is the relation of this gamma is? By using here, it is A into A transpose, but here is B. So that means your target is to prove this one. So but before that you have to prove that this is my non-singular. Fine. What is the B is? A into C. Now the proof is very simple again. You can see that what is the A? A is my non-singular matrix. What is my C? C is my non-singular matrix. So that means the product of them is also the non-singular. So therefore, by the definition of this multivariate normal distribution, C of X will follows the multivariate normal distribution. Mean is C of nu, and this is some covariance matrix I call as a D, where what is the D will be? D will be CA into CA transpose. Fine. Now you can open this bracket. What is that? It's a CA. What is the property of the AB transpose? It is B transpose into A transpose. Fine. What is the value of the A into A transpose? It's a sigma. So A sigma is here. So I can substitute the capital D here. You will get the required result of this property. Second result, again this is very important. Again you have to transformation, but what is the meaning of this? C is my singular matrix. Fine. So once the matrix is my singular, the last case was when C is my non-singular. In this case, when C is my singular, then definitely the rank of the C is not equal to P. So I call this is my Q. Then again the transformation of Y is my multivariate normal distribution, but instead of the P, this is my rank of the C matrix. Fine. And the rest of the things are similar. The proof is again very simple. Now what is the meaning of this rank C? That means it has Q linearly independent vectors. Fine. Now because X is the part of the P cross 1 vectors, so I have to transform this into P vectors. So we can expand Q linearly independent vectors to the P independent vectors. How? You can see I need a P cross 1 vector, but it is my Q vector. So I say C is my Q matrix. Fine. Now can I add say E of P minus Q vectors? So I can add P minus Q vectors so that it becomes my here. Now clearly say what is the determinant of this? It is a non-zero because because they are the Li. So therefore this capital D is my non-singular. So once capital D is my non-singular, so by using the previous result, what is the matrix of the dx? What is the rank of this P? This has d of nu, and it will be here. Fine. So once the d is non-singular, then by the previous result you can derive this result. Now what is my d of x? So I can substitute this value. I called z is my d of x. I can substitute this value. What is that? D will be c of and e. If I multiply by x, it will be cx and ex. Fine. Now what is the dimension of this cx? It will be q cross p. What is that? This will be my p cross q of, now it is a q cross 1 because x is my p cross 1. C is my q cross p matrix. X is my p cross 1 matrix. So if you multiply them, it is a q cross 1. So therefore, C of x is the partition of the z. Now z is my here. So therefore, Cx will follows my normal distribution of q variant, because this complete is my p, this is my q. The dimension of the Cx will be q cross 1. So this value will be my of here. Now let's see how you can now I will explain you how you can solve this problem with the help of various examples. What does it means? X follows the multivariate normal distribution of this. That means this mu is my 0. So what is the dimension of this? It's a 3, 0, 0, 0. Always remember, this is always be the column matrix. And what is the sigma is? Identity matrix. So 1, 0, 0, 0, 1, 0, 0, 0, 1. Fine. Now your target is to find the transformation of this. So firstly, what is the y is? y1, y2, y3. Fine. So I can write the transformation as y is equal to cx, where c x will be my x1, x2 and x3. What is my y? The coefficient of the y1, x1, x2 and x3, 0, 1, 1. So I can written here, this is the 0, 1, 1. Minus 1, x2 will be 0 and here. Now your target is to check, because this is my c. Fine. I can compare this y is equal to cx. Now what is your target? To check whether c is my singular or c is my non-singular. This is your target. So how you can prove that singular or non-singular? You can find that determinant. So let's find firstly the determinant. So 0, this is 0 plus of 2, then plus of 1 is a minus 1. So clearly say it's a minus 3, which is non-zero. So once it is a non-zero, it means the matrix is my non-singular. Fine. So once it's a non-singular, it means the rank of this matrix C is my 3, because this is my 3 cross 3. So therefore this y will follows the multivariate normal distribution. The rank is my 3, and because I take the transformation y is equal to cx, so the mean will be c of mu and variance will be c into here. Fine. Now your target is to find the covariance matrix. So this is my covariance matrix. Now can you find these two numbers, c, sigma and here? What is my c? What is my mu? Mu is my 0, 0, 0. So if you multiply this value, c will be here, then you will get as a 0. And this is my covariance matrix. So I can substitute the value of the c, 0, minus 1, minus 1, 1, 0, 1, 1, 2, 0. I is my identity. So 0, 1, 0, 0, 0, 1 and c will be my here. Fine. Now you can multiply them because I is identity. So now you can multiply them. First row, first column, it's 1 plus 1. First row, second column, 0, 1, 0, 0, 2, 0, 1, 0. This will be 0, 0, 2. This will be 1, 0, 4. 1, 0, 0. This will be minus 0, 1. it will be 1 0 0. It will be 1 plus 1 is 2. So the right answer is 2 2 1 2 5 2 here, and this is my required answer of this problem. Make sure that you can check your answer in the examination. This is always symmetric matrix. This is always the symmetric matrix. Okay, now look at that. Mu is always the column vector. Then your target, now it is given that here. What is the meaning of this 7 is? That means variance of x1 is 7. What does the meaning of this? This is my x1, x2 and x3. That means variance of x3 is my 2. What does the meaning of this 2 is? x1 and x3. That means covariance of x1 and x3 is my 2. Similarly, if I write here, what does it mean? It's x2 and x1. That means covariance of x2 and x1 will be 3, and so on. Now, your target is to write here. So can you write that transformation y is equal to cx? What is my c? C is the coefficient of x1, x2, x3. Fine. Now, your target is to check whether c is my singular or non-singular. So c1, 2, minus 3. Now, since you are unable to find the determinant, so I can find the rank. What is the rank is? 1, which is less than of this size, x1, x2 and x3. Therefore, c is my singular. Fine. So therefore, what is my y? Y will follows the normal distribution. What is the rank is? 1. That is 1. And the values are c nu, c sigma, c transpose. So what is the meaning of the n1? That is a normal distribution in the one dimension. Normal distribution in the one dimension. Fine. So now c rank is c is my 1. So therefore here, now my target is to find these two values, c sigma, c transpose. What is my c? 1, 2, minus 3. What is my mu? 0, 0, 0. Remember, mu is always the column vector. So if I multiply them, it is a 0. Then what is the c sigma, c transpose? It's a 1, 2, minus 3. Sigma 7, 3, 2, 3, 4, 1 and so on. Now you can multiply them. It is 1, 2, minus 3. Now if you multiply them, it's a 7 plus 6 minus 6. First number is 7. Then third is 3 plus 8 minus 3. It is my 8. And the third number will be my 2 plus 2 minus 6. It is my minus 2. Now you can multiply them. 7 plus 16 plus 6. So it will be 29. So c into c sigma c transpose will be my 29. So therefore y will be my normal distribution with the mean is my 0 and the variance is 29 is the right answer of this problem. I hope you can like my video as well. If you feel that these lectures are very interesting, you can put a like on my video to support me. Now x follows my here with mu is, always remember mu is a column vector. Mu is always with the column vector. And here then your target is to find transformation of this. So again a very simple, I can take y is 3x1 minus 2x2 plus here. So this implies I can write y is 3 minus 2 1 of x, where c will be my 3 minus 2 1. Then your target is to check whether it's a singular or non-singular. Now since it is not a square matrix, so you have to find the rank. If the rank of this matrix is the number of column vectors or the number of the xi's, fine, then you can say this is my non-singular. And if the rank of the C is not equal to the number of the xi's or number of the column vectors, then we can say it is a singular matrix. So this is my C. Now can you find the rank of the C? So this is my 1 cross 3. So the rank will be 1, which is not equal to the number of the column vectors or number of this 3. So therefore C is my singular matrix. So once the C is my singular matrix, so therefore Y will follows the normal distribution. Rank is my 1 with the mean of C nu, C sigma C transpose. Fine. Now your target is to find these two numbers, C of nu and C sigma C transpose. So I can substitute the value of C, 3 minus 2, 1. What is the mu? 2 minus 3, 1. Remember, this is always the column vector. So can you multiply them? It is my 6 plus 1. It is my 30. Now I can substitute this value. C will be my 3 minus 2, 1. Sigma will be my here 1, 1, 1, 1, 3, 2, 1, 2, 2. And C transpose. So C minus 2, 1. Now you can multiply them. So if I multiply them, it will be 3 minus 2 into 1. So this will be 3 minus 2 plus 1. It is my 2. Then 3 minus 6 plus of 2. It's a minus 1. The third number will be 3 minus 4 plus of 2. It is my 3. Now you can multiply them. It's a 6 plus of 2 plus of 3. It will be 11. So therefore this Y will follow the normal distribution. That's a one dimension normal distribution with the mean is 13 and variance is my 11. This is a variance. It's a 9. It is my 1. I compute as a 3. So let me check. It's a 3. It's a minus 4. It's a plus of 2. Yes, it's a 1. Sorry. It's a minus 1. It's a plus 1. It's a 1. So if it is a 1, then it's a 1. Then it's a 9. So it will be my 9. Fine. So you can get as the normal distribution 13, 9. Okay, look at this another one. X1 and X2 are follows the normal distribution. That is basically because n is my 2. So I call as the bivariate because there are the 2. What does it means? X1 will follows the multivariate normal distribution with the mu1 and sigma, or you can directly write here. What is my sigma in this case? Because it's the 2 cross 2, the variance is sigma 1 square. This is sigma 2 square, and rho is called as correlation coefficient. Fine. So this number will be sigma rho here, this of this. How you can remember that? Because you can see what is the covariance of x1 comma x2. I can written. What can you remember this formula? Variance of x1. What is that? This is the correlation coefficient. So I can found covariance of x1 x2. What is the variance of this? Sigma 1 square, sigma 2 square. It is my rho. So what is the covariance of this? I can denote sigma 1 2 is the covariance. This is rho. This is my sigma 1, sigma 2. So sigma 1 and 2 here. Now again your target is to find the transformation. This is my transformation. So you can write the matrix as C. I can write this as 1 1 and 1 and minus 1. So where C will be 1 1 1 and minus 1. So now check whether it's a transformation is it singular or non-singular. So determinant will be minus 1 minus 1 minus of 2, which is non-zero. Or you can find the rank of this. So 1 1 minus 1. How you can find the rank? You can change them to the row reduced echelon form. R2 minus R1, 1 1 0 minus 2. So clearly say the rank of this matrix is my 2, which is equal to the number of the xi vector, or which is equal to number of the column vectors. Fine. So therefore C is my non-singular. So hence, if C is my non-singular, what does it means? That means this Y will follows. What is the rank of this? Rank of this matrix is my 2. So it will be my 2 times, or sorry, rank normal, multivariate normal distribution, C sigma of C transpose. Now again your target is to find these two numbers. So what is the C? 1 1 1 minus 1. What is the sigma? So as I told you, what is the sigma will be? This is my sigma. So I can substitute here. It will be this number. Fine. So now mu is my, because it's a mu1 and mu2. So you can multiply them. It will be here. So 1 1 1 minus 1. Sigma will be sigma 1 square. Rho sigma 1 sigma 2. Rho sigma 1 sigma 2 and sigma 2 square. This into 1 1 1 and minus 1. Now you can multiply them. How you can multiply them is the first value. Now first row first second column, first row first column, sigma 1 plus rho sigma 1 sigma 2, then sigma 1 square minus rho sigma 1 sigma 2, then this sigma 1 sigma 2 plus sigma 2 square, then sigma 1 sigma 2 minus sigma 2 square. Then I can again multiply them, this plus this. So it will be sigma 1 square plus twice sigma 1 sigma 2 plus sigma 2 square. Similarly this into this. So this will be cancelled out. It will be sigma 1 square minus sigma 2 square. Second row first column, this into this. So these two numbers will be cancelled out. It will be sigma 1 square minus sigma 2 square. This into this, sigma 1 square minus minus plus twice sigma 1 sigma 2 minus minus plus sigma 2 sorry, it's a negative. It's a negative. Fine. So that, and you can see that this matrix, the final answer will be, it is a symmetric matrix. Always remember that this matrix is always symmetric. Okay, look at this another one. Here again is a column vector. Now your target is to find the transformation of this. So again very simple. I consider y1 is my x1 plus x2 over 2. y2 will be here. Fine. y1 and y2 are here. So now you can take that transformation. Y is equal to cx. So y will be y1 y2. X will be x1 x2 x3. So what is the transformation? So it will be x1 x2 x3. So what is the x1? 0.5. x2 0.5. x3 in the y1 0. x1 x2 x3. Fine. So this is my transformation of this. Now this is my basically a C. Now check whether it's a singular or non-singular. Again it is not a square matrix, so we can find the rank of this C. So clearly say the rank is my 2, which is not equal to the number of column vectors. So that means C is my singular matrix. Fine. So therefore Y will follows multivariate normal distribution with N2 with the mean is C nu and C sigma C transpose. That means this X is my multivariate normal distribution. So this Y will be my N2. That means it's a bivariate normal distribution. Now your target is to find the C nu. C is my here. Mu will be my minus 3. Fine. So if you multiply them, you will get minus 1 into 4. Similarly, C 0.5 0.5 0 1 1 minus 2 0 minus 2 5 0 0 0 2 into transpose. What is the transpose of this? 0.5 0.5, 0, 0, 0, 1. Now you can easily multiply them. Once you multiply it, now you can see this matrix is here. Now if you multiply them, it will be 0.5 minus 1. So minus 0.5, it will be the 0. This number will be minus 1 plus 2.5. So it's a 1.5 and so on. So once you multiply them all matrix, you will get this as the final answer. So this is the two bivariate with the mean is here and normal distribution of this. And clearly say this value will be 0. What does it implies? It implies y1 and y2 are independent. So I will teach you the how you can check about the independence in our next lecture, but for this case I will here. Kindly like and comment on my video as well. If you feel it's a good lecture, you can kindly put a comment on this. So again, your target is to find the distribution of this. So I can take y1 is my here, y2 is my this. Fine. So I can write here y2 will be x2 minus 5 over 2 x1 minus x3. So therefore, what is my transformation? So y, this is c, x will be x1, x2 and x3. So can you find the value of the first row? x1 0, x2 1, x3 0. x1 5 by 2, that's a 2.5, x2 will be 1, x3 will be minus 1. Now this is my c. Find, check whether is a singular or non-singular. What is the rank of this c? So clearly say the rank is my 2 because the 2 non-zero rows which is less than of the number of the column vectors. So therefore c is my singular. So once is a singular, so y will follows again the multivariate, again the normal distribution with the rank is 2. That is a bivariate normal distribution. Fine. So you can substitute here, you will get as the bivariate normal distribution. Now I can find the value of the c into nu. C is my here, mu is my minus 3, 1, 4. So if you multiply them, you can see if you multiply this first row with the first element, you will get here. Similarly, for this case, 1, 1, minus 1, 0. This I can write here and then transpose. So if you multiply them, you can see 0 minus 2.5, 1, 1, 0, minus 1. So first row, this value is a minus of 2. This value into this, so it's a minus 0.25, minus of 2, minus 2.25. Second row, first element 5, then it will be plus 0.5, plus 5, it will be 5.5. Third row 0, third row will be minus 2. Then you can multiply them. The first row it will be, so I can write this matrix as here. So this value will be first row, this is a 5, this into this 5.5, this into this, it's a plus 5, plus 5 is a 10 and so on. So you can see it will be here. So it I will check whether it's a 5.5. This this number will be my, I have to check this number. This 5 plus 5 is a 10, 5 plus 5, so 10 is here. So now you can see again it is my symmetric matrix. Okay, look at this another one. If x1 and x2 are the random variable with the mean and the variance and the correlation, that means if you define this the matrix sigma with the variance is sigma 1 1, sigma 2 2, it will be here. Fine, this is given to you such that x1 is there, x2 is this, y1 and y2 are my independent. Then your target is to find the distribution of the x. Now remember, in the all those previous lecture we have found the transformation y is equal to cx because our target is to find the distribution of this y. In this case, our target is to find the distribution of this x, then I will try to write the transformation x is equal to c y, because my target is to find this x. And what is the y? Y distribution of y is given to you. Fine, this is given to you. So what is given to you? Y1 and y2 are independent. So what does the meaning of the independent? So if I write the sigma part for this, mean is 0, variance is 1. If they are independent, so the covariance is my 0. Fine, mu is my 0, 0. Fine, these are my given to you. Now I need to find the x. So from here, because mu1 and mu2, no, mu1 and mu2 are non-zero, because these are the mean of the y. So from these equations, can I write x1 minus mu1? Can you find x2 minus mu2? Yes, you can easily find that. It will be here. Now clearly say, if I consider this is my capital X, this is my C, this is my Y. So can you write the matrix? Y means y1 and y2. What is the coefficient of the y1? Sigma 1, 1. y2, 0. Coefficient of the y1? Sigma 2, 2 into 1 minus rho square, sigma of this. Now this will be my capital C. Fine. Now to check what is the rank of the C. So clearly say that 2 non-zero rows, and it is equal to the number of the y1 and y2. That means C is my non-singular. Or you can also see what is the determinant of the C. It will be sigma 1, 1, sigma 2, 2, and both are my variances which can never be 0. So therefore C is my non-singular. Fine. So you can say C is my non-singular. So therefore x minus y. Therefore x minus y will follows. This is my rank. Having the mean is C mu and of this. Remember, this is for the y case. And I can found the x is mu plus of here. So my target is to find this number. My target is to find this number. Now for this we need a mean of the y. It is given that mean of the y's are my 0. Sigma of the y's are my 1, 0, 0, 1. So I can substitute here. This mean is my 0. This value will be my here. You can simply multiply them. You will get as here. So substitute this value here. You will get the transformation of this x. I hope you can like and subscribe my video as well. We will see the next lecture on how you can check the independent random variable in case of the multivariate normal distribution. Till then, you can simply share and comment on my videos. Best of luck, students. Happy learning.